All right, let's just jump right in. We're going to talk about something that if you write any code at all, you've definitely felt before. How to build a program that you won't absolutely hate looking at 6 months from now. Yeah, we're talking about building for maintainability. And come on, let's be real. Have you ever opened up one of your old projects, to make what you thought was a tiny little change, and suddenly the whole thing just implodes? It's that sinking feeling, right? But the good news is we can totally learn how to avoid that. So that whole situation, we're going to call that the code nightmare. It's that feeling when your own creation feels completely impossible to fix. Let's dig into why that happens. Okay, so check this out. On the left, you've got X, Y, and Z. What does that even mean? Who knows? It's a total mystery. But then look at the right side. Damage, multiplier, total damage. Boom, you get it instantly. This right here shows that making your code readable isn't just a nice little extra. It is the absolute foundation of code you can actually work with. This quote really just nails the feeling. Bad formatting is like watching a glitchy movie. Nobody enjoys it. It's totally jarring, right? It breaks your focus, and it makes trying to understand the plot, or in our case, the program's logic, way, way harder than it should be. So, if that's the nightmare, then what's the cure? Well, that brings us right to our next point, defining maintainability. This is the antidote to all that coding chaos. So a truly maintainable program, it really just comes down to these three simple but super powerful ideas. First, it's got to be easy to read, which we just saw. Second, it has to be easy to debug so you can actually find and squash bugs fast. And third, it needs to be easy to upgrade. But what does easy to upgrade actually mean in the real world? Well, think about a big game like PUBG. When the developers want to add a new gun, they shouldn't have to rebuild the entire game from scratch, right? Of course not. A well-built, maintainable program lets you snap in new features without breaking all the old ones. It's really all about building for the future from day one. Okay. Theory's great, but how do we actually do this stuff? Let's get practical. Welcome to your coding toolkit. We're going to walk through some core principles for writing code that's clean and, you guessed it, future-proof. All right, first up, and we kind of touched on this already, use meaningful names. Seriously. Instead of these generic single-letter variables, use names that actually describe what they do. Think about it. If you're making a K-pop voting system, are you going to use V1 and V2, or are you going to use fan_votes and bonus_votes? One is clear, the other is just asking for trouble later. Next up, you've got to break your code into reusable chunks, and we do that with functions. Instead of having one huge monster script that does everything, you package up specific tasks into their own little blocks. This is a game changer because you write the logic for a task one time, and then you can just call on it again and again anywhere you need it. And this analogy is just perfect. Functions are the Lego blocks of coding. I love that. You build your calculate total block once, and then you can just snap it into your code wherever you need it. It lets you build really complex things without having to reinvent the wheel every single time. Principle number 3 is all about talking to yourself, your future self, that is. Add comments and documentation. A huge mistake people make is thinking comments are just for other coders on a team. No. They are a gift to you 6 months from now. When you come back to some complex piece of code, a simple comment explaining why you did something a certain way can literally save you hours of pain. And that same discipline applies to formatting. I know, it might seem small, but using consistent indents, putting blank lines between your functions, adding spaces in your math, it does more than just look pretty. It makes your code scannable. It lets your brain see the structure at a glance, which is huge. All right, another huge one. Avoid hard-coded values. You'll often hear these called magic numbers. They're just random numbers that appear out of nowhere in your code. They make things super rigid and a total nightmare to update. For instance, look at the bad version here. Where did that 1.1 come from? It's a magic number. If the tax rate ever changes, you have to go on a treasure hunt through your code to find every single place you used it. But in the good version, we define tax rate as a named constant. Now, if the rate changes to, say, 12%, you just change it in that one spot. Done. That's flexible, that's future-proof.
Okay, let's pull all of this together now. We've gone over the principles, so let's see how they look in action with a simple, real-world example, a basic shopping cart system.
So in our little shopping cart, we're putting it all to work. We've got a clear structure, constants at the top, functions below. We're using meaningful names like price and quantity, not X and Y. There's no hard coding because tax rate is a named constant. We built a reusable calculate total function so we don't have to write that math out more than once. And because of all that, it's now super easy to upgrade. Think about adding a discount. It would be a simple little addition, not a massive headache.
So, let's really bring this home. This isn't just some abstract, technical exercise. Let's talk about why this actually matters for you and the cool projects you're working on right now.
Let's do a super quick recap. The best practices are simple, but man, are they powerful. Use names that make sense. Break your logic into reusable functions. Use constants, not mystery numbers. Comment your code for your future self. And keep your formatting clean and predictable. These 5 habits, they're the keys to the kingdom.
And why do we bother with all this? Because you're not just writing code for this afternoon. One day, that Mobile Legends damage calculator you built is going to need an update for a new hero. Your Roblox inventory manager will need a cool new feature. Your K-pop merch bot will need to handle a new photo card set. And on that day, you will be so glad you took the time to build it right. So your next project is out there, waiting for you. The only real question is, how are you going to build it? Are you going to write code just to get it working for today? Or are you going to build something that can grow and last? The choice is all yours.